Okay, so welcome. Today we're looking at graph theory. Here's an example of a graph. It's kind of a connected network of points. And those points are connected, so we have some arcs between them, and this connects everything up. In mathematical terms, a graph is a structure. We usually write G for graph, which is a set of vertices and a set of edges. Okay. And here's another example, so I'll make this a little more concrete. We have just a quick set here. So our set of edges to define our graph is all these letters. That's our set of edges. Then our set of vertices is all of the connections. So we look at A, and A is connected to B. So we have the connection AB. A is connected to D. And that's all the A connections. And we look at B, and we have BC, and then BD. And then finally, C is connected to D. Okay. Now in this graph, you could walk through the graph. Now walk in a graph is a set of vertices that you step through. So for example, let's say I'm going from A to C, but I'm taking the slightly longer route, then this walk could be represented by the set of vertices, not vertices, edges that I walk through. So there we have it. Great. Well, how are graphs useful? Well, let's have a look at a different graph example. Let's say this comes from a map. Okay, so we have a bunch of points, and each of the points are connected by, well, let's say this is a real map, right? So let's say each of these are roads, and each road has a distance that it takes to travel. And let's say we want to go from C to I. So we need to work out a way to get there. Now this sort of complete undirected graph is not so useful. So a technique which could be used is linked lists. This is where it gets more kind of computer sciencey. So let's say we start at C. This is just a general overview of it. And we are not at I yet. So I look at all the places we can go from C. We can go from C to B, or D, or E. Okay, and each of these has a cost, right? So to go to B, we're at a distance of 30 right now. Then to go to D, distance of 24. To go to E, it's a distance of 22. And the way I want this algorithm to work is I'll pick the shortest distance and expand from there. Okay, so we go to E, and just, okay, we look at the options from E. From E we could go to D, but that's already been done. That's already an option. We'll go from E to H, and right now the distance is we had 22 and then another 9, so that gets us to 31. Okay, so then we look at our options again. distance of 30, distance of 24, distance of 31. We'll expand the shortest distance we have, which is 24. So from D, we could go to E, but that's already an option, G or F. I'm going to put this in alphabetical order. These diagrams get big quickly. Okay, so to go to F, that is a distance of 15. So that puts us at 39. At G, that's a distance of 15 again. So that puts us at 39. And then where can we go from there? Well, 30, 39, 39, 31. We're going to expand B. So from B, we could go to D, but that's already there. We'll go to A. And A is a distance of 41. So that's a distance of 78. Should be there. 78. That made it look even messier. Okay, now let's look. We have 31, 39, 39, 78. Remember, we're trying to get to I. So let's expand H. Okay. So H goes directly to I. That's a distance of 12. So that puts us at a distance of 43. And now we can see, yes, that is the shortest way to get to I. So we're there. We can shade this in on our linked list tree. And then we can go back and shade it in on our graph. So we went C to E, E to H, and H to I. So this is a basic search with a greedy algorithm. Another word for this is, I believe this is also called the A-star search algorithm. Okay, cool. So that was basic video. Hope you had fun, and I'll see you next time. Bye.